Nobody should be stuck at a bench pipetting or cutting up samples. I've been there. It really is not a fun thing to do, especially when you have those red flags that are popping up downstream. The value proposition there is to be able to free up the time that a scientist or a technician takes in preparing those samples to redeploy them into other more valuable tasks that are, quite frankly, what the scientist should be doing. Automation is really key for somebody, especially in drug development or preclinical areas where they need to process hundreds and hundreds of samples a day.
Welcome to another episode of the Omni Pod, where we're enabling conversations between life science thought leaders to help you get the most out of your preclinical research.
Today we're talking about pre-sample analysis, scaling up sample lysis in high-throughput studies with upstream automation.
I'm Bill Schick, Fractional CMO, and today I'm again speaking with Gabby Ryan, Senior Application Specialist at Omni. Hey, Gabby.
Hey, Bill. Nice to be here.
This is kind of a hot one right now.
I think it's no secret that there's a lot of changes going on right now in the life science industry. You know, the economical situation plays a part in that as well, and I think looking into automation in every aspect of that, at every part of the workflow, not just downstream with liquid handlers, is going to be a really important takeaway. And Omni has a lot of equipment that can sort of help relieve that pain point for a customer.
I think it's important to note that, sample prep automation is not really for everyone. I think there are definitely some cases where you would not be interested in this at all. It would really be more about that mid to high throughput level. So maybe we start there. Tell me a little bit about who automation is really ideal for and maybe who isn't quite there yet.
Yeah, that's a great place to start. So specifically sample prep, we'll start with some definitions here. So sample prep automation, what I mean when I say that is sample lysis automation. So what happens before an analyte is extracted and then analyzed downstream? The sample has to be broken up, has to be homogenized. Those analytes have to be released into suspension for further extraction downstream. Automation of that workflow, it's not traditional. And I think it's a solution that Omni has provided a really unique piece of equipment for in that space. And the automation is not for everybody, just as in any field, in any automation piece of equipment, like for DNA extraction. An automated DNA extraction or an automated nucleic acid extractor is not for everybody. A huge extended deck liquid handler is not for everybody. And the same goes true for the LH96, which is our solution to automated sample prep. And I think for a customer that's processing or a scientist that's processing 10, 20, 30, 50 samples a week, it's really a case where we're seeing customers processing. They're doing these huge studies. Usually we see in preclinical or drug development is really where those huge studies are really common, and pulling down 200 samples, needing to process those for RNA extraction, for LCMS, to figure out where that drug is going, how it's being metabolized, how it's being excreted. There's a whole array of studies that have to be done in order to deem that candidate safe, right, for the next step. So automation is a really, we found to be really successful in that field, where a scientist needs to, or a team needs to pull down 200 tissues times 6 different organs, and that compounds really quick. I mean, I think just doing math in my head, that's like 1,200 samples. You can imagine sitting at the bench. Bill, I don't think I'd want to do that. Sit at the bench and process 1,200 samples. I think a bead mill, even in our highest throughput, is not suitable for 1,200 samples if we're just going with that situation there. So automation is really key for somebody, especially in drug development or preclinical areas where they need to process hundreds and hundreds of samples a day.
Okay, so thank you. You answered the follow-up question, which is what's the frequency of that? I mean, you would not want to be doing that with a mortar and pestle, but even with a handheld and sometimes even a lower bead mill, you would not want to be running that volume or trying.
Yeah, it gets really laborious, and with the increased time that someone spends opening tubes, closing tubes, putting buffer in, cutting up the samples, weighing them, it introduces a lot of areas multiplied by the number of samples, right? It introduces a lot of potential areas where you can have a hang up or a little small error that isn't detected until hours or days later when that sample is analyzed, the data comes through, the team has time to analyze it, and we're seeing, okay, things aren't meeting what they need to meet, our samples aren't, pinging positive, or they aren't giving us the analysis that we typically see. And that's when the, troubleshooting process starts. And a lot of times I think a customer isn't going to look at that sample lysis or that sample preparation step as a potential troubleshooting mechanism first. I think even as a scientist myself, I might look at the downstream equipment first and be like, all right, what were my controls looking like? What did my calibration curve look like? Seeing that, making sure everything lined up. And then eventually they're going to make their way all the way back to the sample prep and see, or they might not, and they might see, well, some samples didn't get processed all the way. There was still tissue left over in the tube. They didn't get homogenized all the way. So in a workflow where you've got that number of samples, it really introduces potential areas for those small errors that then get extrapolated downstream, because then we're having to have reruns and studies have to be repeated, and that's just time and effort and, quite frankly, money that these teams don't have. They're needing to move on to the next study, the next drug candidate, the next the next checkbox, and we really just need to make it more efficient, I think.
That makes sense. Can you give me kind of the explicit list of red flags that you might see that you are having an issue here that you might want to address and automate your way out of? So what are some of the issues that show up downstream?
Yeah, that's a great one. I think number one, the most, and there could just be one answer here. I think the number one thing that scientists would see is issues on the back end. When it comes to the quality of data that's coming out, or for example, even before you get to the actual analysis step, if I'm extracting DNA or RNA or protein and my quantity levels aren't meeting where they typically need to be, or my purity levels aren't exactly where they need to be, and we're not even making it to that analysis step, those are some red flags that I think I've seen happen in the past that can happen when you don't have an optimized, or when automation needs to be the answer to the upstream sample lysis workflow. I think another thing is, especially in a case where you may have a more manual starting workflow, like a rotor stator plus a stainless steel probe, or a completely manual method like a mortar and pestle, having unprocessed tissue, it just comes down to, I think, wear and tear on the actual scientist doing the work, because it doesn't take, multiple degrees to understand that sitting there and manually homogenizing something times 200 or times 1,000 samples is really no light task, and it's very tiring. And so errors can happen there, where you have incomplete homogenized tissue, person to person differences that can show up downstream, which go back to unprocessed tissue as well. So that can be another sort of area that I don't think a scientist might not realize that, because when you look on the downstream side, if you're processing that many samples, you're just trying to get through them as fast as possible. In an 8-hour day or a 12-hour shift, it's really something that is, I think, overlooked, right? Because until you get to that downstream step, until you start to see that data, you're not going to realize, oh, that little piece of processed tissue actually translated into a poor result downstream, whatever that may look like, depending on the analysis step. So I think we've got errors downstream, errors upstream in the prep. There's even potential area for cross-contamination to happen, especially in a traditionally manual workflow where you're working with something akin to an Omni TH, which is a completely handheld instrument that functions with a rotor stator tip. And if a customer is not using our plastic Omni tips, which are a disposable single-use consumable, they may be subject to cleaning a stainless steel probe, and with that comes a whole window for cross-contamination to enter, and then you have sample-to-sample differences, or data that just has to be completely thrown out and redone because, a consumable or an accessory to a homogenizer wasn't cleaned properly. And so I think those are the big three that we see all the time.
So if somebody decides that it's time to avoid all of those things or solve for those, and they decide to look at automation, tell me a little bit about the LH96 and where it fits into this scheme of things.
Yeah, so it really is the Omni LH96. It truly is a workhorse in the sense of it takes care of everything upstream. So walking through the functionality from A to Z, we have a weighing module that consists of an analytical balance that will, so that's the one part that isn't necessarily automated, is the weighing step. Scientists are still going to have to cut the tissue to the normal size they need, place it on the scale, and then from there the instrument kind of takes over. So you have the option to automatically dilute based on a fixed volume, so every sample gets the same amount, or you can do weight by volume dilution, just depending on the study, depending on what the lab is used to there. The LH will pipette that buffer into the tube, and then there's also a gripper function on deck as well that will take that tube, move it to the sample rack, and that process is repeated in up to 96 samples per run, just depending on the tube size. So you can multiply that by 96, and then once you have buffer and tissue in all of the tubes on deck, the LH will also homogenize your samples for you using a rotor stator based homogenization technology. In the most classic function, this is carried out using an Omni tip, which is a plastic single-use disposable associated with this instrument as well. And we have an 8-channel homogenization arm that will homogenize 8 samples simultaneously, working all the way down your sample rack until all the samples that you placed on deck are homogenized. And then it doesn't stop there. The next step is to reformat. So we will take those lysates and put them into a 96 well plate. And that 96 well plate, and then there's also an opportunity for an additional buffer addition step. So let's say a customer needs to add another buffer to the lysate in order to make it amenable to their downstream assay, like another enzyme like Pro-K or more lysis buffer, something like that. We'll reformat that onto a 96 well plate using an on-deck pipetting arm as well. And then that well plate, so all of those steps that would be traditionally done manually are taken by the LH, and the customer can walk away after, adding all the sample to the tubes, the actual tissue itself, and come back to a well plate that's got lysate ready for the downstream assay. So just depending on the assay, the customer may take that well plate, centrifuge it, pull off the cleared supernatant containing their analytes of interest, and throw that into their analyte extraction equipment downstream, which may be an automated system as well. And so you can see all of the steps that the LH took to basically automate the entire sample lysis workflow, from weighing and buffer addition, homogenization of the samples using rotor stator technology, as well as sample reformatting. And it really is a workhorse, and it's also quite customizable depending on the tube sizes that you're working with, the volumes that you're working with as well. We've got a range of Omni tip sizes for varying sample sizes as well. Anything from a 5 mil tube all the way up to a 50 mil conical tube is typically what we work in. And again, just depending on what the customer is doing, the instrument is really flexible and being customizable, but still locked in so that an average everyday scientist can operate the instrument and onboard their protocols with ease.
Thinking about that, it seems like it would free up a valuable resource, a scientist, from doing that manually by hand, even with a handheld system, to do other things with their time and maybe to do more value-added work.
Yeah, and that's exactly, the value proposition there is to be able to free up the time that a scientist or a technician takes in preparing those samples to redeploy them into other more valuable tasks like data analysis and other higher level things that are, quite frankly, what the scientist should be doing. Nobody should be stuck at a bench pipetting or cutting up samples. It's, I've been there. It really is not a fun thing to do, especially when you have those red flags that are popping up downstream. I think using the LH and taking the time to using the LH and seeing the time that it frees up for the scientist. I think in one study, we have an application that we put out in collaboration with a pretty big pharma company, and they saw, with incorporation of the LH, a 40% increase in throughput combined with an about 40% decrease in the amount of time or hands-on time that it took for them to prepare their samples. And I think that number just speaks for itself. We really don't have to say anything more there. I think 40% increase in throughput paired with a 40% decrease in the time spent is just absolutely insane, and just speaks to the true power that the LH96 has on the front end of a workflow, and being able to take a traditionally manual or even a semi-automated, like with a bead ruptor, they just don't do the job when you're speaking of scales that we're talking about, hundreds and hundreds, even thousands of samples sometimes. They just don't hold a candle to what the LH can do, and those numbers really speak to the true power that it has.
Right, that makes sense. You have a number of companies that are using the LH96 now. What are some of the ways that they are able to refocus their time? We talked a little bit about developing parallel workflows, focusing on downstream processes. Give me a few examples that you've seen.
Yeah. So again, speaking to the true, I think, value that the LH has in a lab, it's almost like there's a series of light bulbs that go off in one's head once they have the instrument in their lab and they're onboarding it and they have it for that one workflow that they have in mind, like maybe their LCMS workflow, and they get it onboarded. They're doing great. They're like, this is the best thing ever. I'm able to actually analyze my data now instead of having to do it at home, or instead of my process taking a week, it's taking us 3 days, right? And then the light bulb goes off, right? And they're like, well, wait a minute. I'm using it for maybe this LCMS workflow, but we also do RNA. We also do gene expression studies as well as a part of that whole picture focus on what typically goes on in a preclinical workflow. And then the light bulbs start going off. And then that's when, so we sort of talk about ceilings that a lab hits in order to get to that automation point. There's a ceiling. So once you onboard the LH, there is a ceiling that one could potentially hit in the lab, where it comes to a point where, okay, we hit a ceiling with our LCMS workflow, but let's start adding on different workflows. So that may look in the form of a lab onboarding more LHs and compounding that even more, that automation efficiency that we see with the LH, compounding that to different workflows is sort of a more future path that we see once a customer onboards the LH and is able to sort of see that efficiency that it lends to their experiment and to their study into other areas as well. Because let's face it, labs aren't just doing one thing. There are many different studies that go on depending on what area of life science we're in, whether it's a preclinical drug development workflow, whether this is a customer processing plant tissue to look at different, diagnostic tests there on the back end to make sure, crops are safe. It really just ranges. I mean, anyone can use a sample homogenizer, right, for various different samples. So it really is, I think, a picture painted there where there's a series of different ceilings that a customer hits, and it's really the efficiency that I think drives it home for the customer. And it never gets old seeing those light bulbs go off in someone's head when they see what this instrument can do.
The with the LH, does it come out of the box just as it is, or can you customize it for your workflow?
Yeah, that's another great point to hit. So there's a degree of customization to the instrument. It isn't like, you can have it any way you want, right? But there is a degree of customization that I think we've seen at one customer site. So at Regeneron, a pretty big pharmaceutical company, they saw the LH, thought it was great, but they were like, we really just need the homogenization side. Everything else we have figured out, and we have sort of remediated with other liquid handlers that we have in our lab, but we really just need like super max high throughput homogenization. And so we were able to rework the LH to really function as an automated homogenizer, or an AH. And they, I believe, I know they have two, they may have 3 or 4, AHs in their lab where you can imagine, rolling off the statistic that 40% increase in throughput paired with 40% decrease in hands-on time with just one LH at another pharmaceutical company. I can only imagine what Regeneron's efficiency stats are like. With 4 automated homogenizers, I think is what they have. They really are able to crank through samples. And again, that customizability really is something that serves the customer that may have parts of what the LH does currently already solved with other liquid handlers, like their Hamilton or another liquid handler. They've already got that part worked out, so they just need the homogenization aspect. And so that can be some of the customization that we see. Also, with the standard offering that the LH does have, there's customization when it comes to the actual application. So a wide range of sample tubes can be accommodated on the instrument, from 5 mil round bottom all the way up to 50 mil conical and everything in between. So really just depends on what the customer is doing, what their sample size is, and that sort of customizability we're, I think, pretty known for here at Omni, and being able to sort of work with the customer and figure out what they need and come up with an offering on our side to meet that.
It's pretty amazing to have something that's so powerful still have some customizability to it and tailoring it to your specific needs. Thinking back to something you said earlier about consistency for downstream, when you sort of take the person and the fatigue associated with processing those samples out of the picture. You then trust the data more downstream. You have a process. You don't have to worry about that variability introduced by a human doing it by hand over days and weeks in some cases, or multiple people, going through the process, whether they're doing it in shifts or however they do it. Having the machine just do it consistently and repeatably, I think has got to be extremely valuable.
Yeah, it is. Again, seeing the light bulb go off never gets old when, I think the scientist would be sitting there. It's like, all right, well, what do I do now? Right. I'm so used to cutting up samples and it takes me a day just to, prepare all 200 samples. And then, they get extracted overnight and then the next morning we're ready. Let's say something goes wrong. Right. And maybe, the samples weren't prepared right. It just is very fatiguing for a lab to have to go through that. And I think the LH really answers that question because it's not, it's lending back the time that I think scientists and labs need in order to do what they do on the back end, which is really where the scientists in these areas shine, is really in the data analysis and pulling everything together and compiling it all to bring, to push that preclinical process forward especially in the pharma industry. So, it really just alleviates the pain and the bottleneck on the front end when it comes to buffer addition, sample homogenization, because I don't think any other company is addressing it like we do.
As a potential customer, I'm interested in learning a bit more. You mentioned a few, I think, case studies, customer testimonials. Where can I get some more information on that?
Head over to the omni-inc.com site, and we've got a whole page dedicated to the LH, and there are several, like Bill mentioned, several case studies. There's an application note that you heard me reference in this chat as well, that have a lot of valuable information as to, number one, what the LH does, but I think what scientists want to see is how it's helped other scientists. And we put together a few case studies with some key customers to be able to convey that message to help you understand how it may be beneficial to your lab. And head over to the Omni site and you can check out all of the resources that we have on the LH.
So if I think that I might be a candidate for automation, maybe I'm on the fence and I'm not sure, what's my best next step?
Your best next step, I'd say at Omni, we're really committed to that customer support. And whether or not you are a candidate for automation, I think we're always open to having a chat, assessing your current context, what you're doing in the lab, what your sample throughput is, all of those variables, and determining what the best homogenization solution is for your context. Whether it's automation or not, we have an entire portfolio of homogenizers that can help in various areas. And we really put our customers first. I think the case studies that we referenced a few times really dedicate that as well. We're always open to chat. So head on over to the website. You can connect with us through there. And again, we're always open to chat, open to have a discussion on how we can help your sample prep become more efficient.
Well, thank you very much. It's great talking to you today, Gabby.
Yeah, it was great. I think we had a great discussion.